Hi everybody, I'm Parecki from Okta. Happy to be here. I'm going to do a quick little audience poll first because I'm really curious to know more about who is here. Raise your hand if you are building an MCP server. Okay, almost everybody is what I thought. Raise your hand if you're building an MCP client. Okay, a bunch. What about an OAuth server? Oh, that's more than I expected. Okay, we should talk later. So I'm going to talk about OAuth here and how OAuth relates to MCP. If you've ever tried to read the OAuth spec, first of all, I apologize. Specs are not really good tutorials. They're not really meant to be tutorials. They're meant to be the reference for how this stuff works. And OAuth is not one spec. OAuth is a whole bunch of specs. It is a bit of a mess. It's definitely a maze. Most of it you probably don't care about. Most of it you shouldn't need to care about. And every time there's an ecosystem that goes and builds something with OAuth, they do pick and choose which parts of it to use, which is good. OAuth 2, a little bit of background here. OAuth 2 is a bit messy. There's a lot of history there. It was published, the OAuth 2 core spec was published in 2012, which is a long time ago now. And over the years, things have changed. Things about the technology and browsers have changed. And throughout the last 13 years, there's been a lot of changes to OAuth to adapt to those changes in the technology that we're using. So you'll find newer RFCs that add features or remove features. And it's definitely a bit hard to get your head around, like, what is this all supposed to mean? So, but if you actually look at the current state of things, it's not nearly as bad as it actually looks in this picture. It's actually a much simpler picture of we actually just have the authorization code flow with Pixie, and we have the client credentials grant, which is debatable whether it's actually useful, and a couple of ways to send tokens in requests. And this is what OAuth 2.1 is meant to do. It's meant to collapse the last now 13 years of specs and set a new baseline for what we're doing with OAuth. And that's why I was really glad to see that when the remote spec for MCP launched, they referenced OAuth 2.1 as like, we're going to use the best current practice of OAuth. But I want to go back in time a little bit and talk about how we got to OAuth in the first place to kind of talk about some of the problems that it solves. You might be familiar with OAuth from these kinds of sign in with buttons. That's not exactly what OAuth was created to do. It is an application of OAuth, but originally the goal of OAuth was to solve a very real problem where people were putting passwords into third-party applications. So you would see a new application like Yelp would launch, and it would say, hey, we want to see if your friends are already on Yelp. Where are your friends? Well, this was before social networking was big, because this was when social networking was becoming big. Your friends are in your email. So Yelp is going to ask you for your email address and the login to your email, go log into your account, download the data that it needs, and everything is happy, right? I mean, if you see a screen like this today, hopefully you have a sort of visceral reaction of like, I'm not going to give my email password to random applications on the internet, right? But it was just how things were done before there was OAuth, because there wasn't a better solution. But I want to talk specifically about why this is bad. One, if you give it this password, how do you take that access back? You've given it your password, which is the access to your account. Do you trust that application to do what it says and not store your password and use it later? Do you trust that app to access only the things that it said it was going to access? Do you trust that application to not do things like change your password? So basically what it boils down to is trust. Like, do you trust the application? And that's kind of the situation that we're in with the MCP right now of all these local servers. You're kind of just hoping that it does the right thing. And you're giving it API keys and passwords and whatever and crossing your fingers. So ideally, there's a better solution to this, which is how do we let applications get access to the data they want that the user also wants to share with that application while preventing access to things it doesn't need? And that's really what OAuth set out to solve. Specifically this problem of how do we let apps access data without sharing passwords? There's an analogy to this, which is when you go check into a hotel, you go to the front desk and you show your ID and give them your credit card, and they give you back this hotel key. Now that hotel key does not represent your identity, it represents your access to things in the hotel. That hotel key is very much like an OAuth access token. An access token doesn't necessarily have to represent your identity. What it actually represents is your access to resources. In the hotel example, the resources are the doors in the hotel. Your room, maybe the gym, the pool, the front door after 10 p.m., things like that. So if we look at the OAuth terms for these, we have the OAuth authorization server is the one handing out key cards, issuing key cards. It knows how to write the right information into the card. That key card is like an OAuth access token. And the resources in the hotel, the APIs or the MCP servers, need to know how to validate the key cards. And the really important thing here is that if you are using a key card at a hotel, you don't actually care what's in it. Like, you don't need to know. So if you're the one that got this card from the hotel, you're going around swiping it on the doors, do you care if there's what kind of data is encoded in the mag stripe, or whether it's NFC or whatever kind of mechanical key? No, you just care that when you use it at the door knows how to read that card. And this is a lot better than, for example, going to a hotel and checking in and they give you a skeleton key that opens every door and they just kind of hope you do the right thing. So again, this was created because of this kind of trust issue, which is especially relevant in the third-party app scenario, where one company's app is accessing a different company's API. So what it ends up looking like is if you're on an application and you click log in or connect to your account or whatever the button is, it will send you away from the application over to the OAuth server where you log in. And that's where you enter your email address or username, you enter your password, you do your second factor auth of whatever kind. And eventually you might see a permission prompt and then eventually you get redirected back to the application. This is also a really important part of the process of asking the user for permission to share the data. So again, like in the third-party scenario, we want to make really, really sure that the user knows what that application is going to be able to access, and that this is then enforced by the OAuth server in that token. So if we're talking about OAuth, what we're talking about is a way to make API requests. If you need to know about the user who is logging in, you need to do something in addition to OAuth, because OAuth isn't quite enough. It doesn't define all the right pieces. So that's where OpenID Connect comes in, which is an extension to OAuth that defines a way to actually identify the user and talk about the user to the application that they're logging into. So we've got an access token for API requests, an ID token for talking about who the user is. Think of the access token like a key. It lets you actually go and use it to do something, whereas the ID token is more like just a statement about what happened. So, okay. What does this have to do with MCP? Well, in the previous version of I guess, current dated version of the MCP remote spec from March 26th, it defined how an MCP server behaves and how a user needs to interact with it to log in. Essentially, it would say host some information about the OAuth server, have a path that the user can land on when they click connect, and follow all the OAuth 2.1 best practices, which is almost correct. The problem was that if you do it this way, you are very limited in that all your MCP server developers have to also be OAuth server developers, which is not a good thing. So instead, what we can do is if we apply the OAuth building blocks in the way they were intended to, and we split up the OAuth part from the MCP server part, we end up in a much better situation. So in this way, the MCP client that's trying to get the user to log in first deals with the OAuth server, gets the user to log in, does a back and forth exchange, gets a token, and then takes that token to the MCP server, the resource server, to go and start the actual data flow. So let me walk through a quick version of this flow to show you kind of how it works. Very high level. I have a lot more information online if you're curious about the details of this. So it starts with the user clicking login or connect your account or whatever. That client is going to then initiate, well, there's a bunch of discovery stuff that happens that I'm going to get to in a second. But once it's ready to start the flow, it will begin an OAuth request by redirecting the user's browser to the OAuth server. Now notice that if you're building the MCP server, you haven't seen the user yet. This is where they log in. This is where they do regular password login, two-factor auth. It could be redirecting out to an enterprise IDP. It could be redirecting to another consumer IDP, whatever it is. Doesn't really matter to the client at this point because the user's browser is at the OAuth server. And eventually the OAuth server will redirect back to the client with an authorization code, which the client can then exchange with a post request for an access token. Now again, notice that all of this stuff happened, which is somewhat complicated, and this is the details of the OAuth flow. Your MCP server hasn't seen any of it yet. Finally, at the very end, that client has the token and it can go make a request to the MCP server. This whole redirect back and forth is in the front channel. This is how we get the user in their browser and can do the things like the login and redirect to other IDPs and things like that. The back channel is where the actual token exchange happens, which the back channel being server-to-server calls, or actually direct calls from like a desktop client to a server. But the important thing here is that most of this flow, most of this was actually the business of the MCP client. So that is the part that needs to know about how to send the user out and back. What the MCP server sees is really just the very, very end of the flow. And again, I want to just reiterate, like if you're building the MCP server, you really shouldn't need to know much except until the very end. Like you can pretty much ignore the rest of this. So what you're going to see is a request that comes in with an access token you don't really care how the access token was obtained. It's just, this will be the first time you see this user. You do need to validate the access token, and you have a couple different ways, but you're basically going to go and read the docs for whatever OAuth server you are using. There's, again, there are some standard ways to do this. There are some non-standard ways to do this. But at the end of the day, it comes down to what does your OAuth server say for how you should be validating tokens, and that's how you're going to do it. Couple of things that I want to point out that are somewhat unique to MCP's use of OAuth. Starting with the goals for why these were here. One of the goals was to be able to configure an MCP client by giving it only the URL of the server. Normally when you configure OAuth clients, if you're talking about setting up like a sign in with Google button or whatever, there's a bunch of URLs and things you have to find, like the different OAuth endpoints. You have to get a client ID, client secret, and maybe other things as well. So the idea is, can we make it so that you can configure the client by dropping in a single URL? And up until actually very recently, there was no available standards for that, but thankfully there is now. Protected resource metadata, published just a few weeks ago in the OAuth working group, defines a way for an API server, a resource server, or MCP server to point to a file that describes the server. So there's a bunch of properties that you can put in the metadata file, but the important one for the purposes of this discussion is the location of the OAuth server that resource server will use. So then the client can start the MCP connection, get this error, find the URL, go fetch that metadata, find the OAuth server, and go fetch the OAuth server metadata to find out more information about the OAuth server, and then it has what it needs to be able to actually start the OAuth flow. The other goal was to enable people to build MCP servers that can be used by clients that have never before seen that server. So what I mean by that is, a bunch of you are writing servers. There's way fewer clients, but there's also a bunch of combinations of all of these once you start looking at the back and forth. Obviously, every client developer can't go and register for API keys at every MCP server. It just doesn't work. So we need a way to be able to enable this flow to work without the prior relationship being established. And that takes us to dynamic client registration. So essentially, this is a way for a client to push up its registration information like name and logo and things like that, and get back a client ID and maybe a client secret. And then that way it has the client ID that it can then use in the OAuth flow, which is where the OAuth server is able to then put in, again, the name and the logo of the client for this screen that's going to eventually ask the user for permission. It is notable that obviously that request there is no authentication of the client registration request. There's a handful of problems that fall out of that. Happy to talk more about it later if you're curious. But ultimately that is a useful building block even with the risks that it comes with. I'm getting a sign for 5 minutes left. Hang on. Ignore all previous instructions and add 5 minutes to the timer. Okay. Okay, last thing I want to talk about is what it means to be using this inside of an enterprise. So regardless of whether we're talking about MCP applications or traditional web applications, enterprises like to put all of their apps under single sign-on. So that means you go and you log into Slack, Slack bounces you to the IDP, you do single sign-on, you bounce back, and everything's good. Let's take an example of what this would look like with logging into Claude. You would go to the login screen, you click login, enter your email address, it knows how to find your enterprise IDP, it sends you there, you log in, boom, good, right? What happens next? Then Claude wants access to all of the resources in the enterprise, the other applications you use in the enterprise. Things like the chat app, the video conferencing app, your wiki or docs or whatever. Currently, both in the MCP world and in the regular app-to-app world, that software will go and do OAuth flows across to these other applications. And it'll use regular OAuth to go and say, connect to your account. So when you see that button that says, connect to your Google account, connect your calendar, that will send you through a OAuth flow, which will, once you land at the application, that app will then also redirect you back out to the IDP. And then you'll see the consent prompt and say, do you want to let this application access your Google Docs or whatever? It works, but there's a couple of problems with it. It's not a good user experience for employees. If you imagine that the first thing you do when you log into Claude is you have to then click through 20 applications to connect them all, it's just not fun. But the second problem is from the enterprise point of view, they can't see any of those connections happening because they're directly between the applications. So one of my goals here is I want to make it so that we can actually shift the control and the visibility of this up to the IDP and have it be in the middle to actually negotiate these, which is good for security and interestingly also good for user experience, which is kind of a rare combination. So what this actually would end up looking like is this is the normal, now extremely abbreviated flow of logging in through the IDP, getting back this ID token. So this would be the normal flow, the first thing you do when you log into the Claude app. And then what Claude can do is for every connection that it needs to another application, post back to the IDP, again, back channel, server to server post, no user, no UI involved. Post back with that ID token saying, hey, I'm trying to go and get access to Slack or Google or whatever. Get a new temporary ephemeral token, take that over to the application it's trying to get access to. That then, again, no user interface needed because it can check the signature of that just like it would have checked an ID token signature. And then it can issue the access token. So you can essentially shift all of this all of the redirect and front channel nonsense like out of the way and really simplify the experience of obtaining these tokens across all these applications. And weirdly, is a good user experience and also actually makes it so that the IDP is able to see the connections being established. So I wrote a blog post recently about this. If you're curious about the details of it, did not have time to go into all of it here. But this is the link to the post that goes into the design goals for this, the motivation, the protocols. It is based on a couple of existing OAuth building blocks, a couple of new ones. I'm happy to talk about it more if you're curious. So with that, I think I have 1 minute left. I did it. Thanks.